Okay, I think we're live.
Hey everyone, welcome to the Howdy Partner Show. My name is Kripa Dixit, and I'm a Senior Partner Solutions Architect from AWS. With me, I have Olabanji Soaga. Olabanji, do you want to quickly introduce yourself?
Yes. Hey, everyone. Good afternoon. Good evening, where you're from, wherever you're listening to us from. My name is Olabanji Soaga, and I'm a partner solutions architect here at AWS. And it's good to be here once again. Thank you for joining us.
Absolutely. So, Olabanji, we're here for the Howdy Partner Show. Can you talk a little bit more about what Howdy Partner is?
Sure. Once again, welcome everyone. Howdy Partner is a weekly Twitch series that highlights AWS partners that have built innovative solutions and have been validated by AWS solutions architects. So we bring on partners that have a differentiated solution and demonstrate the solution to our viewers.
Awesome. So for today's session, we are bringing on Gyst Technologies, and we have Dan O'Sullivan, who is the CEO of Gyst, joining us here. Hey, Dan. I think you're muted.
Muted.
There we go. Hi there.
Thank you so much for joining, Dan. Really appreciate your time. Since you're here, can you please quickly introduce yourself and also talk a little bit more about your role at Gyst Technologies, and also give a brief overview of what is Gyst?
Absolutely. Great to be here. Thanks for the opportunity. And I am the founder and CEO of Gyst Technologies. We're in the contact center speech technology business. And my own background, I've been in contact center speech technology for about, I'd say, over 20 years. Mostly on the software development. My background is electrical engineering and computer science. I'm a technical founder. This is my third startup in the space, and I'm very excited today to have the opportunity to present our technology. The company itself is headquartered in Houston. That's where I am now. But we sell worldwide with a focus on North America, Europe, and South America. So again, great to be here, and thanks everyone for joining.
Oh, absolutely. We're so excited to have you. So Dan, what do we have? What do you have for us today? Are you going to provide the overview of the product and also demo? Can you give an overview of the agenda?
Yes, absolutely. So I'm going to cover the basic business benefits of the technology. Well, first of all, I'll cover what it is, what it does, and then I'll go through why a contact center, in particular one that's using Amazon Connect and Lex, it would be in their interest to take a look at Gyst and what it does for Connect and Lex. Big picture is it basically, the number one benefit is it saves costs. It helps callers to self-serve more so in an IVR application and also in a Lexbot. So I'll get to how it does that in a little while, but the economic point of the product is that the more callers that can self-serve in the IVR, the fewer that have to be handled by an agent. And agents typically cost anywhere from $3 to $6 a call, depending on their skill levels. In banking and finance, it can be as high as $6 or $7 per call. Whereas automated calls such as Connect and Lex are anywhere in the 10 to 20 cents range. So there's a strong incentive on the part of particularly medium to high volume inbound contact centers, some of which get tens of thousands to hundreds of thousands, up to 1 million calls per day. So that's the primary benefit. Secondary and also important benefit is it improves the caller experience. and I'll demonstrate how it does that with one of our videos in a little while. And then the third benefit, which is important, is Gyst Analytics, which basically is a very high resolution analytics reports on caller behavior in the IVR. Every conversation turn the IVR takes, we microanalyze it and report back on all, very important information like what kind of friction callers are experiencing, whether touch tone would be better than speech in certain IVR call paths, and so forth. So that's what I'll do after the economic and business benefits is I'll dive into the actual implementation in Connect and Lex and so forth.
That's awesome. And you brought up a very good point around the problem statement that the product solves for, right? So other than the economic benefit, it's also a customer experience, and that is no one wants to be on the call waiting for the agent to like pick up and support, right? And that is the value of self-serve, and especially now with given that all the applications are integrating with AI, and then AI is doing much of this kind of like grunt work. So we see organizations leveraging self-serve implementations, especially around the contact center space, to reduce costs, to better customer experience, and also that minimizes the amount of operational overhead that the supervisors have to invest in as well.
Absolutely. Yeah, I think that's a good point, that the more callers that can self-serve in the voice channel with the mundane, repetitive kind of calls, the more agents are freed up to handle the intricate, the ones that need more attention. And so there's less, and companies have done studies on this, there's less agent burnout. The agents, are in a different mood if they're using their skills to really handle a call that requires that one-on-one interaction. And conversely, if they're handling the same call over and over again that could be automated, that shows up in overall in the experience too.
Yeah, absolutely. And the other thing that we don't talk about often is the amount of effort that goes into like training the agent as well. So with self-serve, this also allows the agents to like ramp up at their own time, right? So that's another benefit to this.
Oh, absolutely. Yeah. So overall, I think, it's an improvement in customer experience and satisfaction. It's a reduction in costs. And the analytics themselves are a great way, to get really, really deep and high resolution insight into every single path a caller takes through your voice bot or through your IVR call script.
Awesome.
Yeah, good. So I guess with that overview in place, we can go ahead and bring up, let me see. Are you going to get my screen going? Here we go. Okay. So I don't seem to have control of the screen right now. Oh, that's a problem. It's not scrolling for me. It's just giving me a still image.
You can perhaps like stop the screen share and start again.
Yeah, let me try that.
Let me know and I can bring you back up. Bring the screen back up.
Okay.
Meanwhile, folks who are listening in, if you have questions, feel free to drop it here in the chat.
All right. Let's see how that works. Oh, that's not good. Yeah, let me see. Present. Yeah. Share screen. Just the Chrome tab. There, can we see that?
Yep.
You can see that okay?
Yes, we can.
Very good. All right, great. Sorry about that. Okay, so here, let me show you, again, this is a sort of bullet points here of what we just talked about. How much does ineffective voice service cost you? This being for a contact center. You know, when callers really want to, it's kind of like the old days with ATMs. You know, bank customers really wanted to use the ATM, but you know they had to be easy to use. It's the same with IVR, and you know I've been in IVR long enough to know that it's gotten. And I think, in my opinion, justifiably a bad name over the years, because I think that had a lot to do with the fact that a lot of voice applications and call scripts were very poorly designed. But, you know, today, I think with products like Amazon Connect and Lex and, you know, intelligent voice assistants, voice recognition and so on and so forth, I think, you know, obviously they've gotten a whole lot better. But the point here is that the callers calling in, they really want to self-serve, just like with the ATMs. But, you know, they have a threshold. And if it doesn't work for them, we all know this, you know, if it doesn't work and it doesn't work pretty soon, they're going to get frustrated, and then they're going to just zero out, or they're going to hang up and call back in, and they're already frustrated. And again, they can take that frustration out on your agents, but you know it makes the call longer. It's not a good experience, and it costs the contact center a lot of money. So what I'll do is play a short video here that kind of explains how Gyst addresses this problem. Let me just set it up here.
To your contact center, they're far more likely to be using their smartphone and dealing with poor mobile signals and a lot of background noise.
Can you guys hear the video?
Yes.
Oh, you can. Very good. All right. Let me see. I think we might have started a little bit in. So yeah, here we go.
Today, your customers have come to expect intuitive and personalized user experiences as the norm. And when they call into your contact center, they're far more likely to be using their smartphone and dealing with poor mobile signals and a lot of background noise. Or they may be dealing with distractions in the office or home. Or they may even be calling you from their car while trying to focus on driving. On top of that, each of your customers have their own unique cognitive, language, and other communication skills. They may also have limited familiarity with the call flow of your voice application. It's no wonder callers struggle to self-serve in the voice channel. Gyst solves this problem by allowing your voice system to adjust the speaking rate a little faster like this, every time the caller responds with skill and accuracy, as compared to other callers using the exact same voice application. And it slows down like this when the caller is slower or less proficient. Gyst can also enable your voice system to provide additional instructions when a caller is struggling more than usual compared to your other customers, or to simply allow additional time for the caller to respond when the Gyst algorithms detect this situation.
Okay. So basically there, you know, to sum that up, the technology does essentially what humans do in real conversation, whether it's in person or over the phone. We're just so good at it, we don't even realize we're doing it, but we're constantly adapting, you know, to suit the audience. You know, if we get signals that the listener doesn't understand, and if it's in person, there are visual cues, body language, and so on. If that's the case, then we tend to slow down a little, give a little more information, and sync up that way. On the other hand, if you have a listener who's, seems like they're maybe getting bored or said they'd like the conversation to move along, we automatically just adapt to that situation too. So the idea in a nutshell for Gyst is to allow your voice channel, and when I say voice channel, I mean your IVR plus your voice bot or your voice bot only, as long as you're self-serving in the voice channel. It allows it to adapt in real time to suit the skills and preferences of each individual caller. Okay. Now, what's important about it is that our algorithms, and I'll get into this in a little more detail soon, but our algorithms at every conversation turn, right? So a conversation turn is the voice system prompts the user to enter a bank account, last 4 digits, a zip code, say yes or no, whatever the question is. But and then the caller responds. So that's one conversation turn. If I call into my bank and use the voice help service, I may want available balance, transfer funds, and check on savings account, something like that. And I might use 8 conversation nodes out of a potential maybe 400, 500, 600 that are available to me in the call script. You might call in and you just want to transfer funds and see if a check cleared, and you might use a different 4 or 5 and so on. So the point is that the technology ascertains at every single conversation turn. It asks a simple question that's it's fairly sophisticated in terms of software algorithms. There's machine learning and software algorithms involved, but it asks a very simple question. At this conversation turn, how are you performing compared to 1,000 other callers that went through this same conversation turn? And if you're performing really well, relatively, then it will speed up the audio playback by a certain amount. And now you're listening at, let's say normal conversation rate is 100%. Now you might be listening at 110%. And now you're listening to the next prompt, which might be enter, the last 4 digits of your phone number. And if you, again, same question, how you doing compared to everybody who answered that question? And if you're relatively good, you might go from 110 to 114, and so on and so forth. And the exact opposite happens, same principle, in reverse. And I think, so if you're at 100 and you're struggling a little, it'll go down to maybe 94%. And if you're struggling still, it'll go down to 90. And there's a practical limit. We generally stay somewhere between a low of 85 and a high of about 122%. But that's basically how the basic Gyst technology works. There are other features, but that's the basic. Okay.
So, Dan, what type of voice application does it support?
So yeah, it'll support any kind of voice application that has a reasonable amount of interactivity with the caller. So what do I mean by a reasonable amount? It will not work that well for something like a call steering application that just says press 1 for sales, 2 for marketing, and so on. But if it's at least, I would say, 50 seconds long and at least 2 or 3 interactions with the caller, then it will work. And it will work better the more interactivity there is. Okay. So if you have a 3-minute average handle time in your self-service channel, it'll do better than a minute and a half. But the types of voice applications are anything that fits those parameters, right? So, and what works particularly well is voice applications that have user authentication up front, right? So think of banking, credit cards, utilities, government services, travel tends to work very well, airlines and so on also, because they tend to be lengthy. You have to identify your departure city, your arrival city, your departure date, your arrival date, so forth. So but the more interactivity, the better. But basically any vertical from government, federal, state government, to financial, to healthcare, to travel, and so forth.
Awesome. So for organizations who want to test it out, do you also support like POCs? If yes, like how long are these POCs?
Oh yeah, absolutely. In fact, let me go back here and I'll show you some success stories. Okay, so here are some deployments we've done: retail banking, healthcare, telecom, travel. I'll come back to this and dig in on one. But here is the outline of a test drive, or a POC. So we can basically have a POC delivered in about 2 weeks. And it's particularly easy for Connect and Lex users. What we do is we basically ask you for the customer, that is, for to export. Just simply go to Connect and export a copy of the call flow for Connect. If it's a Lex bot, just export the bot. And then what we do is we will instrument that cloned copy of either application or both, if needed, instrumented with the web API calls that are required to implement Gyst. We get that enhanced version of your existing voice application. And important to point out here that there's no change in the flow or content of the messages or anything like that. We just enhance the application with Gyst. And then you basically run that in testing, in A/B testing mode, side by side, with and without Gyst. And I'll show our analytics later on, but basically they will help you know exactly how many more callers self-served in the IVR. If your handle time was 97 seconds, it'll show it went down to 85. What percentage of callers, not only additional callers, opted to self-serve in the IVR, but how many actually achieved a goal in the IVR, right? Because it's not much good just having them constantly stay in the IVR if they're not achieving their goals, such as get my account balance and so forth. We'll also, and actually, let me go to a case study, because this is a good way to see. Let's see, we'll take this one. So this was a travel. Okay, so this was, now this was a long IVR script. It was about almost 3 minutes. And so what was significant here was caller engagement in the IVR. And this is over, I want to point out, this is over about 40,000, 50,000 phone calls over the space of a week. And in the A/B mode that I described, with and without. So it's a valid test. Engagement in the IVR increased by 21%. What I mean by engagement is...
Hey, Dan, sorry to cut you.
Sorry.
Someone's asking a question if this is the same like Amazon Lex conversational AI bot, chatbot.
No, this was an on-prem IVR. Okay. So it was not a Lex bot. It was an on-prem IVR. I should point out, actually, that brings up a good point. So we've been around a number of years, and prior to becoming an AWS partner. We developed our software years ago, and we proved it in production on tens of millions of phone calls at enterprises like the one I'm showing here. We basically proved the technology out at customer sites, banks, travel, healthcare, but it was on-prem software. Okay, the customer bought a server, a Windows server. We installed our software, and they basically invoked our software from that on-prem machine. But yeah, so this one is not an AWS installation.
In terms of the product itself, Dan, how different is it from when you utilize Amazon Connect and Lex together for self-serve capabilities? What additional benefits would a customer get if they were to use Gyst versus traditionally setting it up themselves?
So the idea is that Gyst is additive to whatever they have. Okay, so a customer, already running Amazon Connect and Lex with let's just say a 1 minute call flow in Connect, and then they hand over to an address change voice Lexbot or some form of Lexbot to handle functionality, and then the caller comes back into Connect. So whatever exists and whatever the customer has designed, Gyst will enhance that in a way that it will improve the performance. Okay, so it won't add any functionality. It won't add a new bot function or a new IVR call script branch or anything like that. But it'll basically take what the customer has today and make it more efficient, make it more productive for the caller, provide analytical insight, and increase the use of Connect and Lex in doing so.
Okay, awesome. And in terms of the deployment itself, would that be something that is deployed, that will continue to be deployed on Gyst Technologies AWS account, or is it something that individual modules get deployed on customers' AWS account?
Yeah, so we have let me share here. I should put my glasses on, it'll be easier. Let me show you here. So how the customer gets it. So here we are on Marketplace, and we have two delivery models. We have a SaaS model that is basically handled by ourselves. We just give the customer a private IP address that we set up everything for them, and they're good to go. Then we have our newer, a more recent AMI model. And what's cool about this is all of the software, and I'll dive into that in a little bit here, but all of our software is basically on an EC2 instance. And this AMI essentially takes a snapshot of that EC2 instance, and we deliver that through Marketplace to the customer. So the customer can then spin up that instantiate an EC2 instance from that AMI in their own account with their own, firewall security groups and everything else. And so it's a really safe way for them to try this out. So then it's an AMI like any other AMI. We provide also, to make it easy, we provide a CloudFormation template. And yeah, I'll get into this now. When we're done on the business side, I'll get into the technical, and I'll show you how there's a Lambda function that we deliver as well. But we made it very easy. You basically you get a copy of the AMI from Marketplace. You bring it inside your own AWS account. You run our CloudFormation template. It spins up the whole technology stack you need to run it. And so then the only other part is the implementation within the application itself. So we basically we've made it pretty easy for somebody to get up and running, as I said, within about a couple of weeks.
That's awesome. What's great about this is also when you're operating in like regulated industry where customers are not open to sharing data in like a SaaS type of like setting. So this is perfect for them.
Yeah, and I'm glad you brought that up. It brings up another great aspect of our personalization technology. We do not. Gyst is all behavior driven, so it goes back to, like I said earlier, how are you performing in the call right now, answering conversation turn by conversation turn compared to everybody else that's used the same healthcare voice app, travel app, banking, what have you. How are you doing? And if you're doing well, you get that experience. If you're not doing so well, and so forth. In that process, no personal information is exchanged. So yes, you're right. Number one, it has the benefit of being in your own, in the enterprise's, the customer's own AWS account. But number two, even at that, there's no exchange of bank or personal information. So yeah, so it's what we call anonymous personalization. Yeah. So all right, if that's good, I'll go back. There's one other video I want to show you on the analytics, if I can. So let's go back to. All right, so we've covered all of that. So here's the analytics, and I'm gonna start it and just make sure you can hear the audio. Okay.
IVR applications have evolved.
Can you hear that? Okay.
Yep.
Great.
From traditional directed dialogue flows to using natural language, AI, and intelligent voice assistants. Optimizing these complex voice applications becomes increasingly difficult as more and more services are added. Finding out what works, what doesn't, and where and how your applications need some redesign becomes a real challenge. When implemented in your voice application, the Gyst API is called every time a caller responds to the dialogue flow. In milliseconds, Gyst's advanced software and machine learning algorithms calculate the user proficiency score at the current dialogue node. It uses this score to update the node resistance value. This value represents the aggregate friction your callers experience at the node. Gyst also computes and generates the recommended CX parameters for the next conversation turn. This process repeats for every conversation turn the caller takes. Gyst Analytics dynamically calculates tons of behavioral data generated by your callers as they navigate their way through your voice applications. This includes performance results on Gyst CX optimization. And you can see how many times Gyst tunes the audio speed to match your customers' conversational styles. You can even track specific node sequences your business and marketing teams are interested in. And you can instantly see which dialogue nodes cause the most friction and struggle points for your callers.
Okay, so what's really important, I think, a couple of points. Number one, as you can see, the analytics are really very high resolution, very detailed, and also with the evolution of speech recognition, machine learning as applied to speech technologies, and the advancements in products like Lex and so forth. Enterprises are just automating. I mean, it's great to see. They're automating as many processes as they can, from address change and so forth. And these are the kinds of repetitive, mundane tasks that really belong in an automated process. But as those systems grow, I noticed like on the Amazon Lex page recently, there's now like this cool feature for a network of bots. It's almost like you have an army of bots that are deployed to your enterprise to field all those questions. But logistically, you have to know how they're doing, and it's important to know which ones are performing well and which questions are too difficult for the caller. Even, in my experience, I've seen sometimes just either a poorly worded voice prompt or even more subtle and ambiguously worded voice prompt can confuse a caller, and just, that's all it might take to turn them off. So what's nice about the analytics is that you're getting instantaneous feedback in real time based on that node friction index, which, now think about that metric for a minute. It's really, it's your callers, your customers, as they're navigating in the voice application, they're voting that score based on, we keep track how many experts went through there, how many people were not expert but they were good, how many people were normal, how many people were novice, and so on and so forth. And then we're also adding in how many timeouts there were, how many no input, no match, and so forth. So so that's really important. And on the question here, languages, absolutely it works. In fact, it'll work in any language. The technology is actually context and language independent. So not only is it language independent, just the algorithms don't even know what kind of question is being asked. So think of, sticking with English, was think of something simple. Would you like checking or savings? And the caller says checking. That's a binary, simple, I know what I want. And so our algorithms will calculate for that that conversation node. An expert might be 1 or 2 seconds, a slow might be 2 or 3 or 4 seconds, and most people should get it right. And so it'll put all that in its algorithm, and it'll use machine learning to say, okay, here's what we're going to do at this yes no node. And also it's important to note that that's an easy binary question. Do you want checking or savings? But there are other questions that are binary that maybe they may have to think about. So all of that gets kind of embedded in the algorithm. So, but we don't know that. The algorithms don't know that. They just know how people are performing at every conversation node and proceeding accordingly. Okay.
Yeah. And just like we have a user here who mentioned that you can use this data to train Lex to make it more useful. Like exactly that, right? Chatbot design is a key element when it comes to like building contact centers and deploying them. So this data can be very crucial in terms of understanding, are there any specific questions that are more difficult for the end users to understand? And if yes, in the next iteration, you need to like revise it to make it easier or give more time for them to like answer questions. So great
Exactly.
call out.
Yeah, exactly. And in my years in the contact center business, that's a legit point. The other legitimate points are, as I said earlier, as they are evolving and changing, and you get new features, or a bank gets new banking products, and so it's in the application flows and the bots are in a constant state of flux. Another aspect is like with the holidays approaching now. Okay, a lot of call flows need to change based on seasonality. So these are call flows are things that change dynamically. When even a really good voice user interface designer designing a call flow for a bot or an IVR, they can do a good job. But at the end of the day, you need this kind of feedback to say, hey, you made a change here and it worked great, but you made another change here and it's not doing so well. So that feedback is really important, Jim. Okay, so let's see. That's the analytics, the economics. I'm going to dive into the technical now. But any other questions on the business side before I do that? I mean, we can always come back to it. I would encourage folks to take a look at these. These are all, as I say, production examples. Oh, I did want to hit on this. So engagement in the IVR by 27.22%. So again, that's the caller staying in there and getting information out of the IVR that you got to look at. If they're not, the questions that the caller, your customer, wants answered, and if they don't get it from the IVR, they still want it answered. They'll either be unhappy they didn't get it answered, or they'll take up time talking to an agent to get it when they could have gotten it in the Lexbot. First try error messages. We've seen this really go down quite a bit. And the first try, I think, are really important, because in a conversation flow, when you're moving along, if you're error-free, it's I think a big deal, because it encourages you to stay in and persevere in the IVR. So we've seen that go down. And we saw a 7 seconds reduction in handle time here, but we saw an increase in self-service rate. This one was kind of small. That's because this was a bank, and banks tend to be short. I think the bank was about maybe 80, 90 seconds. But yeah, anyway, so this is all good data. So I'll move along now to the technical side, and show you how all of this gets implemented. So.
Oh, did we lose Dan?
I think we lost Dan. He should probably join back in a minute or two.
I'm excited to know more about what is under the hood and how it leverages Amazon Connect and Lex.
Me too. And I'm sure our audience are also interested to learn more about what works under the hood. So let's give Dan a minute or two. Oh, here he is. 1 second.
I lost you for a moment there. Okay.
Hey, Dan.
Hi. You can hear me okay?
Yes.
Very good. Very good. All right. So I was going to just dive into the technical aspects now. Let me do that. Let's see.
We've been getting some really good questions. Team, keep that coming.
Oh, great. Yeah, I love it. Okay. So you can see my screen still good, right?
Your screen is not up yet. Let me know when you want me to bring it up on stage.
Yeah. We're ready now.
I still don't see it.
Oh, you don't see my screen? Okay.
No.
Darn. All right. I hope this still works. Chrome tab.
Oh, there we go.
Okay. You can see it? Yep. That's good. That's good. Very good. All right. So starting off here, I'm going to show you where all our software lives. And basically a plain old EC2 instance. We run on Windows Server. Right now, what are we using? We're using a T3X large. I think we could probably get away with, a T2 medium. Depends on the volume. We limit our server capacity to 1,000 concurrent simultaneous sessions. Only for the reason that, if you want more than that, it's probably best to do to have a load balancer, some auto scaling, and so on and so forth. But think of each Gyst server as an EC2 instance running Windows 2022 server. And that's basically the core of our software. Now, let me just think of where to go next. I think actually, so there's a Gyst console, and this is basically a very small web app that lives on this EC2 instance, and it's available for the administrator. I'm going to come back to it in a little bit, but for right now, it's got a movie in it that I want to show you. That the movie's very helpful in understanding. Let me see. All right. Yeah. So our this is the Gyst console, and it has all of the Gyst documentation, and it's very well laid out. It's technical. It has, for example, a little bit on the Gyst CX product, which is the personalization product. It has technical description of the features. It has an example of some of the analytics reports, which we'll come back to later. It has a full API reference. And our API reference, we publish it on Postman. It's available. So there's tons of good documentation here. But main reason I'm here is for this. Is to kind of give you an overview technically of what I'm going to run through here. So let me play this. This is like less than a minute.
Gyst is easy to implement in your Amazon Connect or Lex Voice applications. All of the files and documentation needed to get up and running are located in an S3 bucket and readily available from your own AWS account. Our CloudFormation template builds the required Gyst service stack for you automatically. This includes a dedicated EC2 instance with its own private IP address and the Lambda function needed to access the Gyst Web API. Also included are the Amazon Connect and Lex VoiceBot demo applications. This lets you see how easy it is to implement Gyst in your own Connect and Lex Voice applications. This is all provided from the privacy and security of your own Amazon Web Services account.
Okay, so yeah, just wanted to give you an overview there. That's a like beginning to end how we implement this. The video and the documentation's geared towards technical audience. Also on this page, there's some, we went through our FTR and our WAR with Amazon, and we've done 2 of those. Actually, we just did it again in April. But so there's some helpful diagrams here. Shows you the makeup, like here's your EC2, here's your Lambda, which I'll show you now in a minute. And Connect and Lex, connect via HTTP. There's the AMI I talked about earlier. So yeah, so there's some great documents and diagrams here for explaining the technical overview that I'm going to dive into now. So we'll come back to that later. So
Dan, just a quick call out.
sure.
So we have some users mentioning that the font is too small for them to see.
Yeah, I was worried about that. Yeah, let me see if I can. It probably didn't help too much, did it?
Someone has a question about if we can make API call to get data. For example, if users asking about when flight will depart, when we call flight API to get this information and respond to user or something like that.
So can we make an API call to get data? For example, if a user is asking about when a flight will depart. No, that's more of a Lex application. If I'm understanding the question right, that's more of a LexBot implementation feature where you would add, an intent, a LexBot intent, and a slots to allow a user to get that information. So yeah, it's important to point out here. This is that's a good question for an implementation, but the answer to that question lives in whoever designs the voice bot, that they're able to do that. Now, if they do that, or if there is a Lex bot that is achieving this, getting flight information, then we can definitely make that operation smoother and more likely to succeed. But we don't actually do the application feature bot implementation. So again, think of Gyst as geared towards a contact center that is using Connect and Lex. And let's say it's a bank, and there's tons of them out there, and they've got their own Lex bots that they've had, they're for a year, 2 years. They've got their own Connect instance that they're running, and they're just going along handling tens of thousands of calls a day with their Lex bots and their Connect instance. So we're not going to add functionality. We're not going to say, hey, your Connect and Lex instances, will provide this new feature where you can get your bank balance, or you can get your, in this case, a flight departure. Yeah, so it's all about making what the customer currently has smoother, better, more successful, and therefore, more likely to result in calls in Connect and Lex versus, I shouldn't say calls, calls answered successfully in Connect and Lex versus without it. Okay.
Good
I
call
changed
out.
the layout a little bit so
Sorry?
that I changed the layout a little bit so the
Yeah, I see that.
more
Good.
visible
Yeah,
to
hopefully that. And I wouldn't. My goal here is not to drill down and show you each part of this. I'm happy to do that on, at the end of the session. We'll have and Olabanji, I think I sent you on a link where folks can sign up. Just all we need is your email, your company, and we'll set up a one-on-one to drill down in detail. But right now, I want to cover all the components, but I wouldn't worry too much if you can't basically see the fine detail. Right now, I'm on a 27-inch iMac, and I have it blown up as much as I can. So let me know if it continues to be a problem, though. We'll see what we can do. So let's see. That's the EC2.
Oh, lost that again. For those of you who are just joining us, my name is Olabanji Soaga, and I'm a partner solutions architect here at AWS. And with me today, I have Kripa. Kripa, you want to introduce yourself real quick before
Yeah.
Dan gets back?
Thank you for your time, everyone. My name is Kripa Dixit, and I'm a senior partner solutions architect with AWS. And today we have Gyst Technologies, founder and CEO Dan Sullivan with us.
All right.
Who's walking through Gyst CX and Gyst Analytics.
Yeah. All right. So let's move this over here. Let me share again. Share. All right, we good?
1 second. Let me quickly just reintroduce what we're doing here to viewers that are just joining.
Okay.
For those of you that are just joining us, welcome to Howdy Partner, a weekly Twitch series highlighting AWS partner network partners that have built innovative solutions and have been validated by AWS Solutions Architect. And today we have Gyst Technologies with us, and in person of Dan. Dan, could you just quickly reintroduce yourself?
Sure. Hi, everyone. Dan Sullivan. I'm the founder and CEO of Gyst Technologies. We have been in the contact center speech technology business for about 20 years. And we develop, in particular, software that improves the caller experience and reduces costs for contact centers. specifically today, we're covering our Amazon Connect and Lex implementation. So basically how our software runs and integrates on Amazon Connect and Lex, and how it can be applied for any of the contact centers that use those technologies.
Thank you.
Okay. So, okay to proceed with a technical presentation?
Yep.
Great. All right. All right. And we did have some questions earlier about the font size. I have it blown up as big as we can make it here, but let me know if that continues to be a problem, and we'll see what we can do. So I had just covered, and just for the benefit of the folks that are just joining, I had just covered how our software resides on a standard Amazon EC2 instance. In this case, we're using a T3 extra large. I can. Yeah, there we go. It's a Windows server. So basically we provide this to the customer as an AMI in Marketplace. So basically, the customer can go here to the Marketplace, and just like they would any other product on Marketplace, they can get our AMI. When they do that, they are basically getting a copy of this. Let's just show it here. Yeah, basically they're getting a copy of this EC2 instance. So that's where our software runs. That's it's basically the goal, the purpose of this EC2 instance running our software is to expose our web API. So it's called via simple HTTP GET and POST, and it's ultimately called from an Amazon Connect voice application or a Lex bot. And I'm going to show you how we do that now momentarily. But as I go through that, just keep in mind that the Gyst server is an EC2 instance. It's a Windows 2022 instance running our software. So moving on to the Lambda, this is the Lambda that we provide, and I won't go back and play it again, but we have a CloudFormation template that spins up these resources. We provide the EC2 AMI, and we provide the Lambda, and we also provide some demo, an Amazon Connect demo script, and also a Lexbot for the customer. So,
Dan, quick question.
yes.
So which all regions is this solution supported in? AWS regions?
Yeah, all regions. We do need to know, I think, ahead of time, if it's outside of Europe, North America, we provide a different CloudFormation template. But yeah, it'll work in all regions. And it'll also, and we covered this earlier, work for all languages. So yeah. All right, so this is the Lambda. It's a short Lambda in Python, and this basically is, let me show you here. I won't go into too much detail, but you can see from down here, this here, line 76, that IP address, see if I can make that a little bigger. Yeah. That's pointing to that EC2 instance I just showed you. In production, it would point to ideally a load balancer with auto scaling, and maybe a couple of EC2s. But that's basically the private IP of the EC2 instance I just showed you. You can see on line 82 here that part of how we implement this speed up, slow down, for that, there are other features of the product, and I hope to get to them in a little bit. But the basic is of the adapting of the audio playback in real time, and we achieve that through SSML. And any of the folks on in the audience, that have worked with SSML, I'm sure they'll recognize this. But the tricky part, or the real value of Gyst, is, as I mentioned earlier, is in knowing when to speed up and knowing when to slow down, and not only when to do that, but by how much. Think of it as keeping track of a caller in real time as they go conversation turn by conversation turn. How have they performed early in the call? How are they doing now? How are they doing compared to other callers, using at the same conversation turn? So there's a lot goes into coming back with what you can see here actually is literally the Gyst recommendation for what to do. But this Lambda function then is basically called, and I'm gonna cover that now, but it's basically called from the voice application. And let me just kind of go back here.
There's a question in the chat.
Sure, sorry about that. I should check that more often. Yes,
Oh,
we do have a marketplace listing, and I don't want to do that.
You have 2 marketplace listings currently, right?
Correct.
One is a SaaS type of offering, the other one is an AMI.
Right. The SaaS the SaaS is we spin up an instance for you. We provide you with a private IP, or rather a dedicated IP, and the AMI is basically an AMI. It's an Amazon machine image of that EC2 instance with all of our software, with our console, with the analytics, with everything. And also with this, but it's not advertised here, but because it's relatively new, is a CloudFormation template that builds the whole technology stack for the customer in their account. So it builds the EC2, it puts on the security groups, it puts in whatever network, if there's a load balancer option, and so forth. So it'll basically do everything for you. So yeah.
Yep, thank you.
Sure. So that's EC2 and that's Lambda. Now, all right. So now that we know what that the Lambda calls the EC2, let's take a look at how the Lambda is called rather from a connect flow. Okay. So here we go. So here's one example where this was a demo flow. And basically, we're invoking a Lambda function here. And let me see if I can do it with this side. Oh, good. Yeah. Doesn't work for every screen. That's why I was hesitant to try it earlier. But yeah, so this is where the Lambda function is invoked. Mm-hmm. There are some, now this is part of, I remember, Kripa, you asked me earlier, how long does a POC take? And I said about 2 weeks. So this is what we would do in those 2 weeks is when you export, you can export your Amazon Connect call flow. It just gets exported to, I think it's JSON or YAML, but you export that, send it to us for an application you'd like to try this on. And we then instrument it with these calls. And so it's basically, we're going to invoke the Lambda that I just showed you, which will then in turn invoke the EC2. And there are some parameters here, which I won't dive into, but there are some parameters. These are basically the API parameters that are required. Let me see if I can do another. Yeah, so these are the API parameters that I talked about here in the documentation. Okay, so and they're described in great detail here, the format and so forth. So there's tons of documentation for a customer that wants to do this themselves, but basically this is what we're seeing here. That's a one-to-one correlation. So that's Connect. Now let me see. I want to move on to Lex. So let's say we have a Lexbot, and this is just actually this is I think a bot that we found on the Amazon Lex. Yeah, it's some of the one of the sample templates. There's one for banking, healthcare, travel, and so on. We pulled the banking one out, and so basically, what I want to point out here is that this particular bot, with its intents, um, very importantly, it uses a code hook to a Lambda function. Okay, that Lambda function is basically, I'm sorry, it's not that one. It is this Lambda function that basically handles the dialog flow for the bot itself. And so basically, let me see, I want to blow this up so that you can see it, because this area is important. Let me see. No, it's not letting me. All right, so this screen is not letting me magnify it. Let's see. All right, so this here, this is what I want to draw attention to. This is the bot Lambda, right? So this is the off-the-shelf. Anybody can go to Amazon, the Amazon Lex homepage, and from there you can download this bot. This one is the financial services one. All we did to implement Gyst in this bot was add code on lines 55 to 80. And basically, if you're familiar with Python and programming these Lexbots, implementing these Lexbots, you can see that basically we're just invoking that Gyst API Lambda. I'm sorry, it's here on line 70. I hope you can see that. But we're basically in this code here, we're just invoking the Gyst API Lambda, and we're sending to it, really importantly, the event data, which is coming in turn from the Lexbot, right? So as the user, the caller engages with the Lexbot is calling the bot Lambda, which is the one we're looking at here, and it in turn, for every conversation turn, is sending that event data to the Gyst API, which in turn is calling the EC2, and the EC2 is keeping track of, hey, this is from session number 23, bot session 23, and this caller is on their fourth conversation turn. They've been doing pretty good so far, and they're doing really good now on this current conversation turn. Let's speed them up or proceed accordingly. So again, I know there's a lot to cover here in the time we have, but let me summarize all of that as follows. We have an EC2 where all of our software runs, and that's this fault. And then we have a Lambda, our Lambda we provide that interfaces with that basically allows your Lexbot and your Connect flow to call the software, the web API on our EC2. Then what I covered was the Amazon Connect flow, where you invoke that from, or alternatively, or in addition to, your Lexbot Lambda function, where you can do the same. So basically, I'm going to check back, see if there's any questions here. Yeah, so basically, that's the flow. You take a Lexbot or a Connect flow, and you are ultimately just calling our web API from it. It's returning that recommendation I showed you earlier that basically says, hey, speed up, slow down, or and it's doing that individually for every single caller in real time, and it's also doing it anonymously, so there's no personal information here. Interesting point with Gyst is you could call your bank, a bank that's using your Lexbot to get change of address, or let's say your available balance, or pay a bill. And you could call it and interact with it, and then, you know, hang up. I'm sorry, on the first go, you could get like an expert, you know, experience. It could move along, and so forth. Possibly because you're in your office or at home, and you're not distracted, and you're not multitasking like you know, on the web at the same time or something, and so you can focus on the prompts and react accordingly. You could call the same, you know, bot back 5 minutes later on your cell phone or in a distracted environment and behave differently. And so that's a big part of the goal of Gyst, is to be flexible and to basically adapt in real time, so that you as the caller are more find it a more I guess a friendlier interface, you know, easier to interact with. And the nice thing about this is, you know, it's good for the contact center because it increases self-service and saves, you know, a ton of costs for them. But they can also brag about their customer experience and you know, customer service, because it will definitely improve that. And then, of course, the analytics too. So if that's okay, I'll just move along.
Sorry, we lost Dan again. For those of you who are watching and are having a hard time with seeing what Dan is presenting, there is an opportunity for you to request a one-on-one demonstration with your company. I'm going to paste the link on the screen and in the chat, so please look out for that while we wait for Dan to join again. And for those of you who are just joining, welcome. My name is Olabanji Soaga, and I'm a partner solutions architect here at AWS. And with me, I have Kripa. Kripa, I'm gonna introduce yourself real quick.
Hey everyone, my name is Kripa Dixit. I'm also a senior partner solutions architect with AWS. And Olabanji earlier has also pasted marketplace related links for Gyst Technologies. So I highly encourage you all to check out the product and also look at different deployment options that Gyst currently has. And if any of those interest you, please feel free to like use it for some time and see what the results are. Alternatively, you can also directly reach out to Dan here, and he is offering to help with the POC to help build that business case.
Let me paste Dan's contact again. So, yep. So you can contact him. That's his email address at the bottom of the screen. Feel free to reach out to him. While we'll wait for him. And once again, oh, here he is. Sorry about that, Dan.
Okay, I'm not sure what happened that time, but let's see. Did I get as far as the S3 buckets?
I'm not sure.
Yeah, not S3 buckets, but I think we completed the Lambda section. You were about to close it out because you were summarizing the benefits. That's when you lost you.
Okay. So let me just go over then to present here.
So folks on the line, if you can take some time to also complete the survey, we would really appreciate your feedback.
All right, so you should be seeing my screen now.
Yep.
Very good. All right, so yeah, I had finished up. Apologies for the outage there, but good to be back. So I'd finished up the Lambda, the Lex, and so on, the implementation. Just keep an eye on the time here. Yeah, so I want to cover the analytics, and the way that's handled is the EC2 instance basically is dumping all of the analytics data it's gathering on every conversation turn, for every caller, for every bot session, for every Amazon Connect interaction, every single one. It's just gathering that in real time, and it's dumping it over here to this S3 bucket, which is basically back up here. Yeah, this Gyst Analytics bucket here is basically spun up by the CloudFormation template, and basically all of these files. There's 8 of them that basically are sent over there in real time. So the administrator or authorized users can basically come in and use. We have this is a relatively new feature, Amazon QuickSight interface. So I really want to make sure the audience can see. Is that visible to you, the performance metric results here? Olabanji, is that clear?
Yeah.
Yeah.
It's visible for us.
Not
Audience,
remote.
please let us know.
Okay, yeah. Let me see. Oh, here we go.
No.
Yeah. Again, some of the screens I can magnify, some I can't for some reason. But anyway, yeah. Can you see this user input errors 1.21? So
Yeah, I can see that. I
Good.
think there should be a way to enlarge your.
Yeah, I just did that, but I'm trying. Let me see. Okay, is that better?
Yeah, great. This is
Yeah.
good.
Okay, so yeah, I mentioned earlier there's a ton of analytics, and indeed there are. So this is an overall summary of how Gyst is performing. And so, for example, let's just see. Yeah, sessions completed. Okay. So here, are the number of sessions. They could be Connect sessions. They could be Lexbot sessions. This is the average call time, 116 seconds. Okay, and so we can keep track of that, and we can use that for A/B testing, along with whatever other stats the customer has. But we keep track of user input errors. And very importantly, nodes completed, how many conversation turns there were on these 3,241 bot or connect sessions. And so, we have nodes per session, and we also, very importantly, have user input errors per session. So remember going back to let me pull that up on the success stories when we showed I didn't want that one.
Quick question here, Dan. How
Yes.
frequently is data updated or refreshed, sir?
Yeah, good question. It is updated every it's programmable by the administrator, but it can be every voice session, which would be a phone call, whether it's bot only or connect and Lexbot, or it can be done every multiple of 8 sessions, so 8, 16, 24, etc. And it's just so that's fully programmable, and the resolution at a minimum is every time the connect logs the end of session, those S3 buckets are updated. Okay. So
And
this
the errors here on the first line item, user input errors, are those that are reported by Lex, or just reports errors differently?
Yeah, that's a good question. So just going back to that, yeah, they are errors that are tracked by Gyst. Lex is reporting it. So when in the API that I showed you earlier, when the API is called from Lex in this case, there's an API parameter called Gyst request. It's the request type. And basically, that indicates whether it was successful, whether it was a no input, no match, and so on. So it's Lex that's, the user is generating the error. Lex is reporting it to Gyst, and we're tracking them all.
Awesome.
That good? Okay.
Yeah.
All right, good. So all right, so this is really good for overall performance. And what you can see here is over time, and in A/B testing, you're going to see user input errors go down, because when we're syncing up an interesting thing happens when you, and you think about this just from a human factors perspective. If you proactively are slowing the audio down for the people that are not cognitively able to keep up, or for the people who are in a noisy, distracted, cell phone type environment, if you proactively slow down, you induce fewer input errors. And that's what we see here. That's this result we see here, the second bullet, first try errors were reduced. And they're reduced significantly, like 15, 20%. So that keeps, in the 20 years I've been in the speech technology for contact center business, encountering an error is really a big turnoff. And it's just, and two of them will definitely send most callers to an agent. So we really focus a lot on reducing not just the first time errors, but all errors. And we see that in the results. And this will all be, come out in a POC with side-by-side tests. All right, I won't go through all the tabs, but some of the interesting ones here are, really interesting ones are, let me see. This one, of course, now is too big. Let me see, there we go. All right, this I think is an interesting metric. You can see here, 100 is 100% of normal. This is the audio speed. And we had, at 110, we had 243 encounters at the 110% of normal. So 10% faster than the greeting message is spoken. And then we had 133 at 114 and so on. But what's really interesting is, and this is very typical of what we see in voice applications, is for these callers here, these 243 that were listening at 110%, they have to qualify themselves through their demonstrated skill to be at that level. In a similar fashion, the 65 that went down to 90, they needed to be down at 90% of normal. So I think that the salient point of this tab and this graph is that a good portion of callers want to navigate or need to be at a level other than this one here, which is what you get today. This is all you get today, 100. Everybody gets 100, even if you want this or this. And so a very, very helpful graphic, I think. Yeah, stop me if I'm going too fast here. There's just a couple of these I really want to get through. Node friction here on this. Let me try to blow that up a little more. Yeah, this is a really, really good. So this is the node analysis. So remember I mentioned earlier, like an application could have 2, 3, 4, 500 unique conversation nodes or interaction points. So what's really cool about this is that the technology tracks every single node in real time, and it comes back with how many input errors. These are the auto-learn. Auto-learn is when the algorithms are calibrating themselves to understand how your callers use the voice application today. And that application, again, it could be a Lexbot or it could be a Connect instance. But these are all the samples that the algorithms take. And you can see they change over time based on how callers are interacting. And so the algorithms actually learn how callers, by these 7 values here, auto-learn 1 through 7. It's basically calibrating the algorithms and then using that information to basically decide, who gets what kind of experience based on their ability. The node friction, on the other hand, is a conversation turn or a just node dependent value. 66 here means that it got a rating of 66 out of 100. So that's a little bit high on the friction. You want to see like 28 is very good. And these are all relative, right? And so basically what I think most people in a contact center care about here is what would be really good. 25 is very good, and 90 out of 100 means there's a lot of friction. 66 is not desirable. Well, basically, in QuickSight or in Excel, these are CSV files, you can basically just sort on node friction and automatically find, you know, your 10 worst performing conversation nodes out of 3, 4, 500, what have you. And again, going back to what you brought up earlier, Kripa, about, you know, folks wanting to know how their Lexbot is doing, and as we change the call flow over time, this is exactly how you'd know how it's doing.
Awesome.
Yeah, good. So there's a session analysis. So think of the conversation turn analysis as node by node, how you're going to how it's reporting on analytics. Then session analytics shows you basically how callers do in a full session. So I go through to get my bank balance, and I use nodes 3, 8, 9, 10, and 12. You go through and you want to transfer funds, and you use, you know, 8, 10, 12, 15, 20, what have you. So think of this as analytics on a per session basis. What's very interesting here is this is the source prompt. Now, these are test prompts, but this is a very helpful feature for understanding, like in a session, you know, what prompts are used and spoken, and where they're used. And you know, again, identifying which ones are causing problems for callers. So just more good analytics. I'm watching the time, so I want to keep an eye here. Let's see.
And then all of these dashboards are customizable, right? So if somebody wants a different visual.
Oh yeah, for sure. Yeah, this is all QuickSight, and we chose QuickSight. It's a fantastic product. The flexibility is fantastic. So yeah, they can take this, and that's the idea. That you know, all of these fields are available here to you. To the data analyst. So I think you know, a data analyst can have a field day with this. They can basically mix and match these any way they want, do custom reports, you know, send it to a PDF, share it with teammates, and so forth. So the last one I'll show you here is that this is the parameters one, and I mentioned this earlier. So this is where you can set how many auto learn samples there are. And this is the report cycle, and the report cycle is the same as the update cycle, which somebody asked earlier, is like, how often does it dump the data to S3? Well, here it would be every 16th voice session it does it. Okay. Now, one really this proactive timeout. So just as a bunch of other really nice features, but this one I'll single out. What we do, proactive opt-out or a proactive transfer. Since we're gathering so much behavioral data on callers as they progress through, let's say, your Lexbot, if the algorithms slow them down to 95, we keep a scorecard for every single session, and the scorecard starts out at 0. If that caller qualifies themselves down to 95, meaning they needed to hear the audio slower, we might add like 5 or 6 points to their proactive score. If they do another slowdown, we might add another 5 or 6 points. If they make an error, we might add 10 points or 12 points. And when we get to a certain level, which you can pre-program, let's say a frustration level of 30 points, we can proactively recommend that they go to an agent, because what that means is they started out at 100 like everybody. They immediately went down to 95, then they went to 90, and then maybe 85. And as I said earlier, there's no point in going lower than that. We could then, one of the other nice features, and this is an advanced feature, is we have what's called adaptive timeout. If we're all the way down at 85, and if they're still struggling, we can give that caller an extra, let's say the application timeout was for 8 seconds. We can say, okay, make this caller, give them 12 seconds. And again, this is going to avoid that, I'm sorry, I didn't hear that, could you repeat that? Which again is a turnoff. It takes more time in the call and so forth. So we can also try alternate wording of messages. So instead of please enter your bank account number, if you're really struggling and we've given you more time, we can say, instead of please enter your bank account, please enter your 9-digit bank account. You'll find it on one of your checks. We'll give you some time to find that. It may make the self-service part longer, but it's going to help keep them in self-service as opposed to an agent. So those are some of the other nice features that are available. Okay, I'm going to wrap
This is
up.
awesome. The data that the dashboard show, these are not something that is available out of the box in Amazon Connect real-time dashboard or historic dashboard. So
Yeah,
definitely the organizations can leverage this for decision making.
absolutely. And yeah, and what we just went into there was just like Amazon, quick site. And yeah, you can, this is the panel that we have, and there's basically these tabs here. But let me show you now. So that's logged in here. You can see the URL into QuickSite at Amazon up here. But what we can also do is we've built this into the console that I showed you earlier, and there you go. You've got the same data available in the panel. And keep in mind that we are now logged into. This would be a client-specific web server. This is running. What we're looking at is running on the EC2 that is also hosting the API. Okay, so everything's on that EC2. That's why when you get the AMI and the Lambda, you basically get everything. And CloudFormation just takes care of spinning all of that up, and it gives you a CloudFormation stack like any other CloudFormation stack. So yeah, and I think as I showed you earlier, embedded in here, and this, what we're looking at, that only goes to a customer, right? So this is in your private account, and you get this website with the latest documentation, basically on that same EC2. So with that, I think I've talked enough, and I want to open it up for more questions from the audience, if there are any.
Thank you, Dan. Go ahead, Olabanji.
Yeah, I guess my question is, do you have like a test environment that those that are listening, if they wanted to try it out, that they could use for that?
Yeah, what we can do is there's a link that to our website. Let me just let me make sure I don't. Yeah, there's a link, and I don't know if Olabanji, if you put this in the chat, but anybody could go here, and we can set up a one-on-one demo where we can drill down to all the nuts and bolts of this, and actually hear it in a Lexbot and hear it in a Connect flow. So I would encourage, it would take more time than we have here to do that level of detail. My goal today was to basically do an overview with some details. But by all means, anybody who wants further information, you can just go here. And Olabanji, if you can put that in the chat, it'd be great.
Did you paste the link somewhere?
No, I had sent it to you earlier, but if I can, let me see. I can just do it now. Yeah, here we go. How's that?
I left for a minute and somehow. Okay.
Yeah, I put it in the chat, so hopefully everybody can get that.
I got it. I will put it here in the comments.
Okay.
Howdy Partner Show. Okay.
So yeah, I mean, to sum up, I think it's important to look at Gyst as a SaaS offering that's available, via pure SaaS where we handle everything, or via an AMI, which comes with a CloudFormation template that the customer can basically take to spin up everything I've talked about today, which it looks like a lot, but it's really just the EC2, which has everything on it. and the Lambda. The CloudFormation spins up those S3 buckets for you. You do have to have a QuickSight account to get the analytics. Actually, if you look in the documentation, another nice feature is, let me go back to that, because there was, yeah, on the console here, I didn't have time to cover this, but on the hard drive of the EC2 instance, we do our own crunching, and this data, which is a summary, I would say, it's not as flexible as QuickSight, and it doesn't have, but it basically will give you a ton of data if you don't use QuickSight. So that's also available. The EC2, by the way, any system administrator can RDP remote desktop in there and basically access that as they would any other EC2 in their own AWS account. So they got full control, full flexibility to administer any of that. Yeah, but in summary, sure, it's considered just a SaaS product that basically takes your Connect and Lex applications and makes them more productive for the caller, more likely to succeed, and therefore more likely to self-serve in the IVR. And in doing that, it uses up more of all AWS consumption of EC2, of Lex, of Lambda, and all those great services. It basically replaces the very, very expensive human answered calls with self-service and cloud consumption, which is still, again, we're talking 10 to 20 cents a call versus $3 to $6 a call. So,
Absolutely. Dan, thank you so much for walking us through the solution, talking about the nuances, different deployment models. We definitely learned a lot. Folks on the chat here and also like those viewing, if you are interested in like a demo, please feel free to follow through the link and request a one-on-one demo to understand the capabilities and see if this is going to enhance the IVR experience for your organization, something you want to leverage. Also, highly recommend you to check out the marketplace listing as well. And if you want, you can also buy through marketplace. And if you have any further questions, you can always reach out to us or even Dan directly.
And also, the survey, please tell us how we did today by filling out the survey. It only takes less than 5 minutes. Please complete that and submit it. And I pasted the marketplace listing in the chat as well, the AMI listing, and here comes the SaaS listing. So whichever one suits your purpose, you can grab the link or just go straight to AWS Marketplace and put in Gyst Technologies, and you should see the offerings there. Yeah, we do not have any questions in the chat. And anything else you wanted to let the viewers know, Dan?
Just that, yeah, we're happy to work with. We have a very hands-on approach with customers. We, if there are any contact centers or technical or other folks on the session that have a customer that thinks they could benefit, and again, that would be somebody in any of the financial, healthcare, government, any of the verticals. As long as the self-service part of the call, doesn't matter whether it's Connect or Lex, as long as it's a minute or longer, and the longer the better, and the more calls they receive, the better. We're happy to roll up our sleeves and do a POC, and as I say, we can do that in a couple of weeks, and show them. What's really nice about the POC is that it's kind of irrefutable evidence. It's their callers using their voice application in A/B results. So yeah, I would encourage anyone with any customers like that they think could benefit, by all means, reach out to us via the form, and we'll put it to work for you. I just, I'll finish by saying I really appreciate the opportunity. Thanks to AWS for hosting this, and thanks a lot to the audience that tuned in and listened. Really appreciate the opportunity.
Thank you very much, Dan, for your deep knowledge, and thank you to all of the audience. Join us again next week, Wednesday, for another Howdy Partner episode, and it's goodbye from us. Talk to you next time. Thank you very much, guys.
Thanks all. Thanks, Dan.
Thanks.
Thanks,
Bye-bye.
Olabanji.